In this video, I will discuss Azure Machine Learning environment best practices and walk through troubleshooting tips. Azure Machine Learning environments are version containers that specify the software packages, environment variables, and software settings around your training and batch scoring scripts. Azure ML provides a set of curated images in your workspace, searchable under the Environments tab in Azure ML Studio. You can also build custom Docker environments locally for faster development and register them with the Azure ML service to quickly transition to scaling up remote training in the cloud. The recommended environment for large-scale distributed training jobs is the Azure Container for PyTorch environment, which is purpose-built for multi-node training and helps reduce preparation costs, speed up deployment times, and reduce costs through accelerated training times. This environment contains several built-in optimizers and is easily extensible with your libraries into a custom environment. For example, it's a one-line update to your Docker file to utilize libraries like Hugging Face transformers to fine-tune the latest open source models. If needed, you can fully specify a custom training environment using a Docker file upload or directly authoring into the UI using the Azure Container for PyTorch as a base image. Some included optimizers are the Onyx runtime, which delivers up to 1.4x faster training with built-in model graph optimizations, DeepSpeed, a PyTorch optimization library for efficient distributed training, scaling models up to thousands of GPUs, MSCCL, an interconnect accelerator communication framework for faster data processing throughput, and Nebula, a fast checkpointing feature that saves large model checkpoints asynchronously up to 1,000 times faster. Microsoft keeps the software stack updated and validated against various workloads, supported by Azure customer support. OpenAI and Microsoft Research use it, and you should use it too. Even if you're just looking to fine-tune an open source model, the Azure container for PyTorch is beneficial. Benchmarks show that using this container, so combining the Onyx runtime plus DeepSpeed optimizations can speed up training by between 39 and 103%. So if you're fine-tuning open source models like BERT, T5, GPT-3, Llama, or Mistral, don't miss out on these performance gains. Before running a large-scale distributed GPU training job, it's always recommended to validate your environment to ensure you can make the most of your reservation. This helps reduce the debugging surface for your Azure ML jobs and with troubleshooting performance issues related to your job environment. By running NVIDIA nickel tests before starting training, you can ensure that your training environment is optimized and ready for efficient and reliable distributed inter-node GPU communications. NVIDIA nickel tests can help you verify the optimal bandwidth and latency of your nickel operations, such as all gather, all reduce, broadcast, reduce, reduce scatter, as well as the point-to-point send and receive. They can also help you identify any bottlenecks or errors in your network or hardware configuration, such as NVLinks, PCIe links, or network interfaces. Please review the example scripts and performance baselines linked on the slide. Next, ensure you can check and resolve any software dependency conflicts by using environment specifications such as Conda or Docker to maintain consistency and reproducibility across different runs. This helps prevent runtime errors and ensures your training jobs run smoothly. The biggest source of software errors we see for startups on the Microsoft for Startups dedicated GPU cluster is related to CUDA when setting up custom environment containers. CUDA is NVIDIA's parallel processing software that's coupled with its GPUs that significantly speeds up performance. I included instructions on troubleshooting common CUDA errors on the slide. First, check for mismatched CUDA and driver versions with NVIDIA SMI within the target environment container. If so, remediate by installing the latest compatible NVIDIA driver. Next, validate the CUDA installation and that the environment variables have been properly initialized. If they haven't, go ahead and update your environment variables to the correct paths. While the Microsoft for Startups GPU cluster instances do have significant memory, CUDA out-of-memory errors can still happen when training large models or from accumulating checkpoints or having too large of batch sizes. You can check memory utilization in real time using NVIDIA SMI and profile memory usage in PyTorch with the CUDA memory summary method. Running the PyTorch profiler alongside your training job can also give you additional insight into memory usage down to individual model graph operations to optimize memory usage further. These resources, along with the Troubleshooting Environment Images guide linked on the slide, provide you with the starting point to troubleshoot your Azure ML environments. For additional assistance, please reach out to your account team or Azure support. That concludes this video on optimizing Azure machine learning environments. In the next video, I will go deeper on discussing how to optimize Azure machine learning storage.